The biggest challenge for human innovation and technology is staring us in the face. The world has about 10 years to cut our greenhouse gas emissions by half, and we need to reach net zero emissions by 2050. What happens if we don't? 2 words: climate chaos. To prevent this downward spiral into doom, we need to act now. And the most promising solutions come from the world of technology. Technology brought us here, and it also has the ability to help us out of this climate change problem. In this video, we're going to go down a rabbit hole of climate technology and look at all the categories and subcategories of technology to address climate change. Some of these technologies help us reduce greenhouse gas emissions. Renewable energy is a good example of this. Other climate tech help us adapt to the adverse effects of climate change. For example, drought-resistant crops, early warning systems, and sea walls. All of climate tech can be divvied up into 3 broad buckets: energy, environment, and infrastructure. Let's start with energy. Energy is considered sustainable if it meets the needs of the present without compromising the ability of future generations to meet their needs. To build a world with sustainable energy, we need renewables, resources, and storage. Renewables are any energy from natural sources that are constantly replenished. Solar converts energy from the sun's radiation into electrical energy. Wind power converts the kinetic energy of moving air into electricity using massive wind turbines. Hydroelectric power uses the flow of moving water to generate electricity using water turbines. Geothermal power harnesses the heat of the Earth's subsurface to either directly heat or cool, or to convert it into electricity. Biomass is the use of plant-based material as fuel to produce heat or electricity. These can be from wood or wood residues, energy crops, agricultural residues, and waste from industries, farms, and households. Resources are materials that are created in nature that are usable or useful to people. Hydrogen, for instance, is abundant in nature, and it combines as fuel with oxygen. This can be a zero-carbon process, at least if used in a fuel cell or an internal combustion engine, where it does not have the opportunity to interact with carbon. Nuclear reactions, either combining or breaking apart atoms, also releases a lot of energy. Uranium and plutonium are commonly used fuels in nuclear reactors. Minerals are essential components in clean energy technologies, which is a rapidly growing sector. Some examples of useful minerals are iron in steel, copper in electrical wiring, lithium in rechargeable batteries, and aluminium in aircrafts and cans. Oil, gas, and transport. Petroleum and natural gas are the world's primary fuel sources. This sector is hugely influential in the global economy. The systems and processes for extracting, refining, and distributing natural gas and oil are complex, costly, and they require state-of-the-art technology. Lastly, storage, which is the capture of energy produced at one time for use at a later time. Batteries. Companies and academia are working to improve the energy density, charging times, capacity, and safety of batteries. Also on the radar are storage batteries for the grid, which is a whole other ballgame. Alternatives. There are some alternatives to lithium-ion batteries, but they're nowhere near as efficient. Some examples are salt or magnesium-based batteries, fuel cells, ultracapacitors, glass batteries, and liquid batteries. Grids and microgrids. The grid is an interconnected network for electricity from producers to consumers. Microgrids are smaller, localized networks that can operate independently from the main power grid. They offer greater resilience and lower cost power for communities and corporations. EV charging. Public and home charging infrastructure, equipment, and services like charging or fast charging stations, and EV charging apps fall under this segment. Peer-to-peer network. It's now possible to earn money from excess electricity that's generated, that is fed back into the grid using either solar power or wind generators. And this network, called peer-to-peer energy network, is also likely to grow as more clean energy technologies become commercialized. The second big bucket under climate tech is environment. And under the environment, we have biosphere, agriculture and food systems, circular economy, carbon markets, data and finance. The biosphere includes all parts of the earth where life exists. Land. Land management strategies have enormous potential to reduce emissions, sequester carbon, and improve human resilience. Land use planning keeps one eye on the evolving human needs and another eye on the ecological health of the land in the long term. Forests. Forests can also be an important tool to reduce emissions from deforestation and changes in land use. Sustainable forestry and agroforestry offer innovative land management strategies to safeguard ecosystem services we need, while also supporting local livelihoods. Oceans and coastlines. A range of technologies already exist and more are being developed to protect the oceans and help ocean-dependent communities tackle pollution, rising ocean temperatures and rising sea levels. Ice and snow. Many technologies are being used to protect ice caps and snow sheets, including satellite imagery. More daring technologies also include building massive protective walls below glaciers and using underwater robots to study the pattern of ice melt. Clean air. Innovations in air quality measurement, monitoring, and purification systems are helping reduce the negative effects of air pollution and allergens. Next, we have agriculture and food systems, which include all the players and interactions along the food value chain. Everything from agriculture and production of crops, livestock, fish, and other commodities, to their transport, processing, retail, wholesale, preparation, consumption, and disposal. The first segment under agriculture is vertical and smart farming technologies, which look to resolve food shortages of the future through innovative and advanced farming methods. Crops tackle challenges like food security, climate-resilient crop varieties, and crop sustainability. The sector is making farming a lot more sustainable and resilient in the face of climate change. Livestock. Advanced technologies like drones, IoT, sensors, and wearables are used in farming to track the health, location, and longevity of livestock. Plant-based and cellular meat, dairy, eggs, and seafood. More sustainable alternatives are being developed to slaughtered meat. Startups are now making realistic, plant-based, and cultivated meat products and quickly closing the taste and texture gap between real and alternative meats and seafood and dairy products. Circular economy. Circular economy is a model of production and consumption that involves sharing, leasing, reusing, repairing, refurbishing, and recycling of existing materials and products wherever possible. Let's start with materials. Different materials are being made at scale without depleting non-renewable resources. These include sustainable packaging like polyurethane, sustainable plastics, artificial leather, and carbon-efficient construction material like cement. Recycling. Recycling involves collecting, sorting, and turning waste material into reusable objects, diverting them from landfills and limiting their environmental harm. A lot of technologies support recycling. For instance, there are platforms that connect individuals and corporates with waste management companies. And there are innovators that are turning hard to recycle material like e-waste to its proper value chain. Solid waste. There are a range of technologies that keep waste out of landfills using sensors, robotics, IoT, and platforms that can connect individuals and corporates with recyclers. Other technologies also convert waste to energy, which is an interesting avenue to explore. Wastewater. Systems to measure and treat wastewater include sand filtration, membrane filtration, and other processes that make use of natural bacteria. In a circular economy, wastewater is considered a valuable resource rather than a liability. Energy, clean water, fertilizers, and nutrients can be extracted from wastewater and used as resources. Textiles. A number of startups are involved in separating textile fibers from waste bins for reuse in clothes and art. Sharing and rental platforms are also increasing in popularity, therefore diverting clothes, shoes, and accessories from landfills. Next, carbon markets. In a nutshell, carbon markets are trading systems in which carbon credits are bought and sold. One tradable carbon credit equals 1 ton of carbon dioxide, or an equivalent amount of another greenhouse gas that is reduced, sequestered, or avoided. Carbon capture and storage. CCS is a combination of technologies used to avoid CO2 being released from conventional power generation and industries. These processes inject carbon dioxide into underground reservoirs so they don't escape into the atmosphere and aggravate global warming. Offsets. Some businesses provide customers with options to reduce or remove carbon dioxide or other greenhouse gas emissions to compensate for emissions made elsewhere. Carbon offset credits show that an organization or an individual is actually reducing their emissions. Carbon intelligence. Carbon intelligence involves a set of technology-based solutions that can manage and estimate the carbon footprint of users. It provides corporations with a strategic roadmap, programs, and services to move towards a zero carbon economy. Carbon accounting, reporting, and ratings. Companies and organizations use processes like these to quantify their emissions and understand their impact on the climate, which also helps them set clear goals in terms of emissions in the long run. This ecosystem helps companies and governments stay accountable to national and global emissions targets. Lastly, climate data and finance. Internet of Things. IoT involves objects embedded with sensors and processing technologies that can connect and exchange data with other devices over the internet or a different communication network. In the transition to a low-carbon future, IoT is finding uses in sectors like agriculture, residential homes, and smart buildings to measure and manage emissions. Climate data, assessment, and forecasting. Tools and methods are being developed to adapt to increasing drought, floods, landslides, and other climate-induced hazards. There are also tools that can bring us quality data and environmental information, like assessment of water information and invasive species. As you might expect, this is an important segment for decision makers worldwide. Climate finance. This includes traditional lending, crowdfunding, venture capital, and impact investing. This sector is an important enabler in funding the transition to a net zero emission future. Climate risk. A number of technologies help companies measure and analyze and predict risks associated with the rising emissions and climate change. It combines the power of satellite imagery, drones, IoT, and human intelligence and more to quantify and describe climate-associated risks. Insurance. Climate insurance is designed to mitigate financial risks and losses linked with climate change, especially phenomena like extreme weather events, which are only going to increase in intensity and frequency over time. The last big bucket under climate tech is infrastructure. Built infrastructure is the human-made space in which people live, work, and recreate on a day-to-day basis. Design and construction. Sustainable construction means building with renewable and recyclable materials. It also means reducing waste and energy consumption in every way possible, as well as protecting the natural environment around the site. Heating and cooling. Smart heating and cooling systems are now being used to reduce emissions, improve efficiencies, and cut down on costs. From sustainable air conditioning to geothermal heat pumps, there are many green solutions being built to lessen the environmental impact of heating, ventilation, and air cooling systems. Residential and commercial buildings. The construction industry is focused on building more affordable, eco-friendly, and flexible homes to suit the future demand for more sustainable places to live and work. The future of construction is also demanding improved efficiency, lower energy use, and better work environments to build and maintain smart residential and commercial buildings. Transport infrastructure. Companies and organizations are also focused on future-proofing the transport infrastructure so that public transport and the systems that support it are more resilient, adaptable, and sustainable. Mobility is the second sector under infrastructure. It is the industry of transporting goods and people from place to place. Micromobility is a range of small, lightweight vehicles that run at speeds below 25 km per hour. These can be electric bikes, scooters, skateboards, and other light vehicles used in the sharing economy. Shared micromobility has the power to reshape urban mobility by offering a sustainable transport option that is widely accessible to people. It can replace walking, cycling, and public transport trips as well as short car journeys. Vehicles. The slow but sure transition to hybrid and electric cars, trucks, and motorcycles has a big role to play in reducing the emissions from the transport sector. As part of their contribution to sustainable transport, these vehicles can reduce air pollution, greenhouse gas emissions, and contribute to energy independence by reducing the import of oil. Rail. Trains are one of the most sustainable modes of transportation, and increasing its share of passengers and freight is critical to achieving net zero emissions. We need more green and electric trains that use electricity from overhead lines, a third rail, or an onboard storage system like a battery or a supercapacitor. Boats and ships. More efficient designs and technologies to harness wind for water transport are helping reduce emissions. Hybrid engines are also being tested at small scale, but the most likely long-term solution for low-carbon shipping is going to come from hydrogen fuels. These include green hydrogen, green ammonia, and fuel cells. Aircrafts. Radical innovation in propulsion technology is required to replace jet fuel. For large aircrafts, a low-carbon solution is likely decades away. But an all-electric solution for short-haul commuter flights for less than 20 passengers is much closer to being commercialized. Startups are making significant progress in battery electric and hydrogen fuel cells for small planes. Personal flying vehicles are also being designed with rotors instead of wings, which allow for vertical takeoff and landing. Apart from these three core buckets, there are also soft climate technologies like climate education, energy efficient practices, and training for using equipment. Climate tech, as you can see by now, is a massive space. It's also a young and vibrant industry that is growing rapidly with the pace of technological innovation. There's so many enthusiastic young players worth talking to in the climate tech space, which we'll definitely do in future videos. For now, I hope you found this one informative, and if you did, please do share, like, and comment with your thoughts. There's a lot more from the bustling world of climate tech coming your way on Biotic. Until next time, this is Kavya signing off.